All right. Guess we'll get started a little bit early here. So just before we jump into material, I'm gonna go through some housekeeping stuff. I wrote it down to make sure I didn't forget anything. So module 1, module 2 readings. There were some issues with the points. I think initially, if you had 2.25, it's essentially got all the points. I'm in the process of kind of turning those into 4 out of 4 points. I believe if you're on Canvas right now, you can see the first module should be updated on Canvas to kind of convert your grade to be for that full 4 points. I'm working on the second one. It's giving me some issues. I'm not really sure why. So if you see me playing around with the due date on either one of those, that's why. The due date is already passed. I'm not changing it on Top Hat. It's just so that when I resync it, it doesn't kind of treat anything as late. So I should have that done tomorrow, maybe even this evening if I get some time to work on it. I also had set so you can now see your grade and results from quiz 1. So that should be under like the grades tab on Canvas. You should be able to see that now as well. I know there was some issues. So how many of you on the quiz had issues with the ones that said select all that apply? So there's a handful of you. So I'm not really entirely sure why. I'm trying to figure it out. So those of you who've emailed me, I appreciate it because I've been asking you what browser you use, what type of computer you're on to kind of figure out exactly why. I reached out to Top Hat. They told me they think the issue, or Top Hat. I reached out to Canvas. They told me they think the issue with that is that you need to either clear your cache and cookies out from whatever browser you're using, or that the safest browsers that don't have the lowest amount of issues with Canvas quizzes is going to be either Firefox. So if you don't have that, then you go out, it should be a free download, and then use that to take the quizzes, or Microsoft Edge. So I'm guessing a lot of you were probably using Chrome and Safari, since those are probably the 2 most popular. I don't understand why those are the ones that aren't the most supported by Canvas, but that's what they told me. So maybe moving forward, just kind of a safe bet. There shouldn't be a whole lot of questions where we have those multiple answers. A lot of that was like syllabus related. So from here on out, it shouldn't, so there shouldn't be a lot of that. But moving forward, probably using Firefox or Microsoft Edge sounds like it's going to be the safest bet. Okay. But as a result, since it was a significant number of you, everyone got kind of lucky. I gave everybody full credit for those problems. So I went back through, it should already be done, kind of had those regraded and then updated those scores on Canvas. Okay. So those were the kind of things that, I had some questions too about Packback. So if you go to like the website, it looks like there's 5 assignments, but you can't access them. I only release them kind of as we cover the material in class. So after class Thursday, that very first Packback assignment was set to be released, and you can start working on it. We'll talk more about it in class on Thursday. At the very end, I'll kind of show you what it looks like because I'll have it set to be released so we can all then see it and exactly how you'll kind of go on, add your responses. Okay, so don't worry about that until Thursday's class. That'll be set to release after Thursday's class. I think I mentioned, Top Hat and class questions. We're going to try to use them today. My earlier section, we had some loading issues, which I've also sent an email about and hopefully get some technical issue responses there. But we'll try to at least use it today. I think I had like 2/3 of the class was able to get on, and then it started being slow. And someone told me the psychology class had a similar problem. So it might be something on their end that hopefully we'll have worked out for Thursday. And I'll start using those in-class Top Hat questions for those participation points. All right. Final thing, just want to mention, because I do think they're very beneficial, those CL sessions, I'm going to come up with tomorrow. I've got all of your responses, what your preferred time. I'm going to sort you all into like different day, time, locations, and then put it like a complete Excel file and kind of show you how to look at that in Thursday's class as well. In practice, it really is just a way for me to guarantee you a spot. If for whatever reason, the time you told me you want to go to a different time and day this week, go for it. In practice, none of these sessions are ever completely full, right? It's just that if you kind of do have an idea what your preferences are, it's an initial way for me to kind of make sure people are getting kind of like evenly spread out across all of them. But if you have to go to one, it's a different day or time than what you told me or what you end up being assigned to, in practice, it's going to be okay. Like there'll be room in the one that you want to try to go to this week. And you can kind of change week to week. Okay. All right. Before we jump into material, any other kind of questions logistically? Yeah.
Questions, but then on Canvas it says it's
yeah, so it won't update grades until after the due date is passed. So if you work on Top Hat and you complete all the questions, you should be able to see on Top Hat that you completed them. It's only going to do a one-time sync at the time of the due date to Canvas. So it'll always be a little bit lagged. Nope. As long as you can see that you've answered and submitted those questions on Top Hat, it will update after the due date and kind of sync up to Canvas. Yep. And I can see everyone. Look, most of you, when I say most, like almost all of you did them, and I can see all the grades on Canvas now. So these quizzes, maybe I failed to mention if I wasn't clear. So these quizzes are meant to be like a little bit easier than the exams. And you should, I think I mentioned, like you should have your notes out in front of you, have the slides pulled up from the week. It's open book, open notes when you take those online Canvas quizzes. So yeah, by all means, have all the resources that you think would help you from class. Like I said, your notes that you've taken. We're going to do a lot of stuff in the dot cam today that you should take notes on. Having that in front of you might be helpful. But yeah, never any restrictions in terms of that. Any other questions before we dive into the new module 2 material here today? Okay. All right. So get this out of my way. Slideshow, current slide. All right. So we're going to kind of set up some pretty simple models today. And obviously the real world is a little more complicated. If we understand how to solve simplified models, it just becomes more complicated math. Right? So first thing we'll start out with, we're going to start talking about production possibilities curves. Let's assume we've got just a too good kind of 2-person or 2-country model here. So you've got 2 countries or 2 people. They can either produce one of 2 things, computers, or I think it said produce, or I think I ended up calling it wheat, right? Some kind of agricultural product. Okay. We have one resource. Now, obviously, you know, they're like, after you did the reading, there's multiple factors of production, but we're simplifying it down to just one to start out with, which is just labor hours. Okay. If I've got 50,000 labor hours a month, I can then think about, okay, do I want to take half of those and put it towards computer production, half of those put it towards agriculture or wheat production, or some other combination, right? Maybe I want to put all of it towards computer production. Okay. If I do that, if I know that, okay, based on like the skill level or whatever of my population, excuse me, it takes 100 labor hours to get one computer, right? They take a lot more labor hours to produce. Okay. I know a ton of wheat, I only need 10 labor hours to produce it. So if I think about it, if I've got 50,000 total labor hours, if I put them all towards computer production, how many could I produce? Well, it would be just 50,000 divided by 100, or there we go, 500 computers, right? Now, if I'm putting all my resources towards computer production, I can't put any towards wheat production. I'm going to end up with 0. We can then think about, okay, that's probably not ideal. My people need to eat, right? So as I start to take labor hours away from computers, right, and put them towards wheat production, I could then think about, okay, here, I've got 40,000 labor hours, 100 gets me one computer, 40,000 divided by 100, I could get 40 computers. And then I've got 10,000 labor hours towards wheat production. I can get a ton of wheat from just 10 labor hours. So 10,000 divided by 10, I can get 1,000 tons of wheat from this kind of allocation of labor hours. And then there's obviously, I only chose 5, but really I could choose like an infinite number, not infinite, because we probably have to do an hour at a time, right? But I can kind of transition these labor hours to the production of the other good. All we need for starting out, we'll just use 5 points to kind of make it a little bit easier. Okay? So once I have these different combinations of goods that I could produce using all of my resources, I could then graph them in what we call a production possibilities curve. So usually I'll leave like a slide blank if, let's say, which dot cam is this? I think it's 2. I'm then going to write something in class that doesn't get recorded in the lecture or the recording that I post. So let's say I've got something like this, and I'm trying to remember how I did this in the slide so I can get this to match up with it, so we're not doing too much work. So let's see, -10, okay. So let's say I wanted to put the quantity of computers, PC, right? And up here, I've got the quantity of wheat, okay? So when I was producing only computers, I could get, I think it was 500 of them, right? So 0 tons of wheat, all my resources towards computer production, I'm getting 500. If I put all of my resources instead towards wheat production, I think there it was 5,000, right? And then I could do all the points in between. Now, this is an easy example to start out with, where I think the next one I had was 4,000 and Well, I probably didn't really draw us to scale. So 100. So maybe what? Here's my second point. And I could plot each one of those points. To start out with, we're going to have this nice, though, linear production possibilities curve. And I could go through the other points there. I think one of them was what? 250 and 2,500. And then this was 1,000. Yeah, 1,000 and 400. Kind of just plot those points and then kind of connect them, right? Because I truly don't, it's not just these 5. I could choose somewhere here. It's just we don't want to go through every single point. So in practice, we really only need the 2 extreme points, right? If I'm putting all of my resources towards the y-axis good, or wheat here, or if I'm putting only towards my x-axis good, which was computers, okay? So what this production possibility curve tells me is that these are the different possible combinations of these 2 goods I can get using all of my resources. But it also kind of embedded in it has something floating behind the scenes that tells me the cost of producing one more computer. So if we think about it this way, if I start out in a scenario where I'm only producing wheat, in order to get that first computer, what do I have to do? Well, I was using all of my labor hours, so I'm going to have to take away labor hours I was putting towards wheat production, put it towards computer production. What is that? It's a trade-off, right? We talked a little bit about that last week. So to produce one more computer, I'm going to have something I can no longer do, or I'm going to have an opportunity cost, right? I'm going to have to give up some wheat production in order to get a couple more computers. What is that cost? It's actually going to be the slope is going to be our cost of that x-axis good, okay? So if I can determine the slope of this line, it tells me the cost of my x-axis good. And it will, hopefully, once we figure out what that number is, it'll kind of make sense, and I'll try to connect the dots here. So how do I find the slope of a line? You guys got admitted here, so right? Some people say rise over run, or you said it the way that I typically do, which is a change in y over a change in x, okay? So if I think about going from this point to this point, what was my change in y? Well, I went from 5,000 to 0, so negative 5,000. What was my change in x? I went from 0 to 500, so 50. So here I get the cost of one additional computer was I had to give up producing 10 tons of wheat, okay? Now, the slope of these products, because there is a trade-off between these 2 goods, it's always going to be negative, right? There's always going to be a cost to producing something because it means I'm no longer producing something else. So in general, when we talk about it, we kind of ignore the negative sign because we're talking about costs. Inherently, we know they're negative. But when you actually do compute it with actual values, you will see, right? The slope is going to be negative here. And what that's representing is that to get one more of the x-axis good, a computer, I'm giving up, right? Minus, I'm losing 10 tons of wheat, okay? Any questions on this idea before we keep moving? And I think maybe a more intuitive description. Sometimes I'll give these descriptions that aren't probably a bad thing in recording because they're not technically the most correct, but it's sometimes a way to be, it makes a little bit more sense. It's easier to remember. So if I thought about before, remember I said it took 100 labor hours to get one computer, 10 labor hours to get 1 ton of wheat. So 100 divided by 10, think about it. I could get, if I produce 10 units of wheat, each one cost me 10 times 10 would have been 100. Or to get one more computer, I would have had to give up 10 of those tons of wheat, right? So in practice, and I think maybe the module readings, you could make this a little more complicated. I'll never start out like we did in this example, giving you the amount of resources and then having you have to determine, okay, how many computers could they produce? How many tons of wheat? I'll generally just start out giving you these quantities, okay? Once you have these quantities, we can find the opportunity cost of that x-axis good, okay? Any questions on that before I keep moving? And it shouldn't be too bad yet. There we go. So, we talked last week about this opportunity cost being what you're giving up or the next best alternative. What could I have done with those labor hours? Now, we've kept it simple, 2 good model here. In practice, I think if you could explain, it's almost like it doesn't even have to be just necessarily 2 goods. Maybe I'm thinking like, do I put my resources towards a set of goods, like this set or this set? And each one of the goods in those set has a different valuation. It just becomes more complicated math. We're only ever going to keep it though at that 2 good model. Okay. So we already talked about the slope is going to be the cost of my x-axis good, right? In terms of how much of the y-axis good I have to give up. So when we had that -10, that meant to get one more computer, I had to give up 10 what? 10 units of wheat, or I think the units I was using there was 10 tons of wheat. Okay, so it's always our cost is in terms of the other good we could have been producing. Okay. Now, what ends up being true is that the cost of our y-axis good is going to just be 1 over our slope. Okay, so I will go in here. So we had the slope was x-axis good. The cost of our y-axis good should always just be 1 over the slope. Here, that would be 1 over 10. Or to get one more of my y-axis good, 1 more ton of wheat, I'm giving up 1/10 of a computer. Okay. Now, if you wanted to, you could prove this to yourself. If I just flipped these, right? So if instead I was like, oh, he didn't tell me what good to put on which axis. So I put wheat on my x-axis. Now, if I find the slope, it's what? -500 over 5,000 or -1/10. Well, remember, the slope is the cost of your x-axis goods. So if you put a different good on the x-axis, the slope now of 1/10 is telling you the opportunity cost of 1 ton of wheat. So you don't have to redraw this out every time. You just only have to do it once. Once you know the cost of your x-axis good, cost of your y-axis good is just 1 over that slope. But if you really wanted to, you could flip the goods and find that same cost doing it this way as well. Okay. But by no means do I, don't create extra work for yourself. If you can remember how to do it this way, that I think that is probably the optimal kind of more efficient way of doing it. Okay. Just to kind of give you some more support here. Okay. Any questions on that before we go back to the slides? Yeah. Oh, hold on. Yeah, I was looking at you. And then we'll come over. Yeah.
Like is that like 1/10 of a computer?
Yep. So it's always going to be in terms of the other good, right? Now, obviously in practice, it's hard to give a 1/10 of the computer, but it's the idea that we really have this continuation, right? And so I can give a 1/10 in a computer in the sense that if I'm only putting enough resources to get 9/10 of a computer, I'm not going to have a full computer. I'm just not going to. So that is going to be the cost, and it's always in terms of the other good. So whatever your x-axis good is, that value, that slope you come up with, that's how much of the other good, the y-axis good, you're giving up. And then who thought I was pointing to them? Who else had a question over here? Oh, so this is if I use the method of calculating the slope's always going to be negative. When we're just talking about things in terms of cost, we generally just don't include the negative sign because we're saying it's a cost. Like it's inherently going to be that we're giving this up, right? So I'm never going to try to trick you like with multiple choice questions and give you some positive, some negative. If I'm asking you for like what the opportunity cost is, I'll generally show you those positive values. We're talking about costs. We know they're negative. Have another question? Thought someone started talking and then we're good. Okay. All right. So it's kind of our toy example here. So this is just going back, once we find the slope of one good, okay, once we find the slope of one good, we inherently know the slope, or sorry, once we use the slope to find the cost of one good, we inherently know the cost of the other good as well, right? It's just going to be 1 over that slope, okay? Any other questions before we move on from this example, complicate things a little bit more? Okay. So with this idea in mind, we just looked at one economy's production possibilities curve. So when you think about costs might vary, right? We might have more than just one economy. Maybe there's 2 countries, probably more than 2, but we'll start out with just a second. So I'll kind of run through a stupid toy example, and then we'll kind of look at how this like a real production possibilities curve. But the CEO of Ford, right, can fix their car in an hour. And maybe there's a mechanic, like they're really good, knowledgeable about cars or whatever. But there's a mechanic that could do it in 3 hours, but they're going to charge that CEO $200. So what should the CEO of Ford do? I mean, he can fix it in an hour, or he can give it to someone who can do it taking 3 hours, and then he's going to have to pay them. So why wouldn't maybe this CEO fix their own car? Yeah, right. The CEO's time is extremely valuable, right? I tried to Google this and I could not find it. I know I heard this story, so I know this is true. Someone was interviewed. I think it was Mark Cuban. If I'm making that up, and it was like Elon Musk or one of these other ultra rich guys, that's okay. Or rich people. I think it was Mark Cuban. They asked him why he didn't fly commercial, right? Or maybe it was someone else who kind of says they care more about the environment. They said, well, look, I waste so much time flying commercial that the amount of my time is so valuable that the amount lost is actually way greater than if I just bought my own plane. So, you know, if your time is really valuable, it might make sense to pay this mechanic $500, right? Because your time is extremely valuable. So we can think about that opportunity cost of each individual involved, it matters, right? Hopefully, we have an economy, if it's running efficiently, people are producing what they have the highest, people are producing what they have the lowest opportunity cost in, or what we're end up going to be calling a comparative advantage. Okay? So opportunity cost is so much larger. You shouldn't fix his own car. Let the mechanic do it, even though he can do it slower, and then, you know, do whatever the CEO of Ford does with their time to generate however many millions of dollars for Ford, right? So this is kind of introduced the idea of you can have absolute advantages and you can have what we call comparative advantage. So an absolute advantage is just if I'm taking all of my resources and you're taking all of your resources to produce one good, I can produce more than you can. I have an absolute advantage in the production of that good. So in our example, the CEO did have an absolute advantage in fixing these cars, right? Because, excuse me, because you can do it in 1 hour compared to 3. That was a lower time cost. He could produce the same car in a lower amount of time. But that time cost, right, we want to factor that in. That doesn't factor into our absolute advantage. It's just, can I produce more, right? We're not factoring in the opportunity cost at all when we're purely talking about absolute advantages, okay? So we might think of a comparative advantage is going to be when someone can produce something at a lower cost. It's maybe they can produce less of it, but they can produce it cheaper, right? So our comparative advantage, if I'm using if we're both using all of our resources, I can produce this good at a lower cost than you, I would have the comparative advantage. So kind of in our example, the mechanic, because their time is not near as valuable, right, could fix this same car, even though it took them more hours, they could produce it at a lower cost. Each one of those hours was a much lower cost than the one CEO's hour. You can kind of think about this in terms of countries, like the US, generally, we have a lot of absolute advantages. If we put all of our resources towards the production of, I don't know, anything plastic, we could probably produce more than most countries, right? But we rely on a lot of other countries to produce these plastic products. Why? Because by producing these small $5 below, you know, the 5 below different goods, by producing those, we're not doing things like, you know, producing rocket ships or whatever else other good we could kind of be putting our resources towards. So let's start out with a kind of easy example. We've got 2 different countries. So I think I chose, and I think I have a typo in my slide here. At some point, I switched my example from India to Brazil, and I forgot to change Brazil at one point. So it's India and then US. So generally what I'll do is kind of give you a matrix that looks like this. And it's going to indicate if both of these countries are putting all of their resources towards iPhone production, they could produce 60. And, you know, to make it, you could make this 60,000 or million, whatever it is, but we're just trying to keep the numbers kind of easy here. If India is putting all of their resources towards iPhone production, they can get 50. If the US puts all of their resources towards aircraft part production, they can produce 30. India putting all of their resources towards aircraft part production, maybe could produce 10. Okay? So if I look at this, who has an absolute advantage in the production of iPhones? What about aircraft parts? So I start out with an example where one country has an absolute advantage in the production of both of these goods. That is possible. What will end up being true is you can only ever have a comparative advantage in the production of one of these goods in these simplified models, okay? So we already answered these questions. It was the US to both. Okay? So if we think about our production possibilities curve, we can kind of go back and think about what that would look like for each one of these countries, okay? So I'm going to do some work on the dot cam here, but that's the chart I'm going to use, right? All I was doing was just using those 2 extreme points to show that if we're producing 2 goods, what do I want to put here? I want to put aircraft parts, and then what was the other? Oh, iPhones. So I think the US was 60 and 30. Here's their production possibilities curve, right? That was the US's production possibilities curve. India was 50 and 10, right? So much steeper, right? So we can start to think about if the slope is telling us the cost of our x-axis good, who's going to have a lower cost here? We don't even have to work through the numbers yet. As my curve gets flatter, what's happening to my slope? It's getting, what's the slope of a horizontal line? 0. So it's getting closer to 0. It's getting smaller, right? So flatter slopes are going to represent lower costs. So here, before we even work through the numbers, we know that just based off of the visual I drew, I guess you're kind of trusting that I drew the slopes proportionally, that the US is going to have a lower cost to aircraft part production, or what we say is a comparative advantage. But we'll work through the numbers, okay? So for the US, what's the slope of their PPC? That's going to tell us the cost of the x-axis good or aircraft parts. Well, once again, rise over run or change in y over the change in x, going from 60 to 0. So I guess if we want to be technical, right, we're going down 60, and then 0 to 30. So we get what, -2, right? Or how we would usually phrase it, the cost of one aircraft part is 2. What are we giving up 2 of? Producing 2 iPhones. Okay. I could then do the exact same thing for India. Theirs would be what? 50 over 10 or -5, or the cost to India. And I'm using colors here. You know, if you're taking notes, maybe, write. You don't have multiple colors. This is for India, and this is for the US. Okay. So the cost of one aircraft part to India was 5 iPhones. Okay. So who has the lower cost to producing one more aircraft part? 2 is less than 5. It would be the US. Right? So we would say the US has a comparative advantage in aircraft part production because they have to give up fewer iPhones to produce that one aircraft part. They are doing it at a lower cost. Their opportunity cost is lower than India's. Okay. Everybody with me up to this point? Okay. Now, instead of drawing this out and flipping them, this is where it becomes pretty useful to say, okay, well, what is the cost of an iPhone to the US? Well, we said the cost of our y-axis good is just 1 over the slope. So here, this would be what? 1 over 2. And I'm not going to include the negative signs because we're already talking about these in terms of a cost, right? So the cost of one more iPhone is going to be half an aircraft part to the US. And then you would do the exact same thing for India, right? So cost of an iPhone, India, 1 over the slope, so 1 over 5. So it gets kind of tricky here, I guess, when we're dealing a little bit. If I don't put the actual value, I just got the fraction, but which of these is a lower cost? Yeah, 0.2 versus 0.5. And I think I put the decimal values in the slides too. I know that sometimes fractions aren't as easy to look at. So here, the US had a lower cost to producing aircraft parts, and India has a lower cost of producing iPhones. Right? So you can only ever have a comparative advantage in the production of one good. You can work through a million different examples, and you'll always find that the comparative advantage, right? You can only have a comparative advantage in one. And the reason why, some of you have taken high-level math courses might be like, yeah, no, I shouldn't say that. I need to watch my language. So, but you're like, yeah, that's obvious. Well, anytime you have like a relationship between two numbers, 2 is less than 5. If you take what we call the inverse of them, 1 over that, it always flips the sign, right? Notice 1/2 is greater than 1/5. That's just you could probably Google the math proof if you're really interested, but it's not that interesting. So we can only have a comparative advantage in the production of one good. So once I found that the US has a comparative advantage in aircraft part production, I don't have to really work this math out. I automatically know India has to have a comparative advantage in the production of the other good. Okay. Any questions on this before we kind of go back to the slides here? Okay. So hopefully not too bad yet. Kind of throw some more stuff in here in just a second. So there we are. So we've got each country's production possibilities curve. I think here I actually just flip the goods. Once again, it doesn't matter, right? I could set it up where I had iPhones on my x-axis, aircraft parts on the y. I'd find the slopes. Sure enough, what do I find? 30/60. The cost of this x-axis good in iPhone to the US is 1/2 an aircraft part. That's what we just found, right? Even if we started with them on the different axis and then did 1 over the slope. What's the cost to India to get one more iPhone? The x-axis good, 10/5, 1/5. You find the exact same values. So it doesn't, unless I specifically ask you to give me the slope, then it does matter what good we put. But if I just ask you for the cost of one of those goods, you could set it up either way and still arrive at the correct answer. Okay. Any other questions on this before we keep moving here? Okay. So I worked through this, right? We can kind of see it. I've worked all through this on the dot cam. Sometimes I'll do additional examples on the dot cam, have some stuff in the slides. Just a slightly different way of looking at this. If I then wanted to say, okay, putting all this out there, right? I could work the complete model every single time where I figure out what the costs are for each good for both countries. Then it's just very easy. Okay, who has the lower cost? Here, it's 0.2 is lower, so India has the kind of comparative advantage. Who has the lower cost when we look at 1 over that slope? So 1 over 1/2 becomes 2. 1 over 0.2 or 1/5 becomes 5. It's the exact same thing we worked out here, just starting with flipping them on the axis. Okay. So it doesn't matter which way you do it, you arrive at the same answer. Okay. So I think here is where I want to try to, and we'll see if we have better luck than the other section. So the join code for this class, I think it'll always be this, is 089020. Right? So on your laptop, you should be working on your phone. I think that's the one that people were having the most problem with earlier. But you should be able to go to Top Hat. And I would probably recommend not just going to the Top Hat website, but clicking on the link on Canvas to get there. So click on that Top Hat link. It'll redirect you to Top Hat, kind of get logged on. What I would probably start to get into a good practice of is so you don't have to do it when I pull these open and you're kind of scurrying around. At the beginning of the class, before class starts, just make sure you're logged on to Top Hat so that you have it ready to go. Because sometimes I'll use these questions in the middle of class, sometimes at the beginning, sometimes at the end. So getting it pulled up at the beginning, you kind of have it ready to go whenever we get there. Also, if it is going to be an issue because like we're kind of in an internal building, we're not as close to the outside and there's a lot of us, getting it started at the beginning of class, we will kind of avoid some of these like getting it loaded issues, right, in time. Okay. So I'll hit this. Nope, that's not what I wanted. I forgot. There we go. Now we'll do it. So same join code. I'll start the question. So those of you, looks like 145 of you kind of made it on, or some of you getting like a spinning wheel of death. Yeah. So that's the technical issue that I'm waiting on the response to. Hopefully we get that ironed out and we should all be able to kind of get on. We'll see how many of you pop up. Maybe it is just a matter of we're all trying to get on at the same time, and getting on it at the beginning of class might help alleviate those issues moving forward. So I'll pull something up like this. For those of you who are on, can you see the problem in front of you? Getting some head nods, yeah? So you should be able to see not only this, but I have a limited screen here. I have different options, right? I have 4 different options, and you have to choose the correct one. You can see all this on your device. So generally, this is a little bit smaller of a visual, but you should be able to have it right in front of you as well, okay? So here I would hopefully have been an easy question, because if we're using all of our resources, how many guns could the economy above produce, right? So if I'm looking at this, this is like a stupid old, econ, like original econ textbook. It was, we have to choose between producing goods that are going to protect us and goods to feed our people, right? Guns and butter was kind of the age-old example. So if I'm using all of my resources to produce guns, here I could produce how many? 600, right? So I would generally kind of ask you guys, okay, here's a question. I'm going to give you a minute or two to work on it. Talk to the people around you if you want. Usually when we're doing these Top Hat questions, it gets kind of chatty, and then I have to kind of raise my voice to kind of make sure we close it out and then get to the next one. But that's okay. I think having that conversation with people around you, that's also going to be beneficial. You might know something that the person next to you doesn't. They might know something or might have picked up on something that you didn't, right? So I think that's kind of a really helpful kind of learning process to kind of talk through these things when I give you a little bit of time to work on them, right? Now, if I see people working on them intensely, right? Not just chatting about the day and I see them like drawing and pointing to it, then I'm probably going to be a lot more nice on those questions. And I might give some kind hints before I close it out. I might even work through the problem up here on the board. And if anyone is still awake, they should be then getting it correct. Sometimes, if I maybe, just want to make sure that you are taking it very seriously, I'm not going to do that on every single problem, right? And a lot of the times I'm going to kind of have you try to answer it correctly, half points for responding to the question, half points for getting it correct, okay? So looks like maybe it is just a timing issue. Looks like more and more of us are getting in there. So hopefully kind of getting logged on at the beginning of class, we can kind of avoid this bogged down issue. I'm guessing that's probably what they're going to tell me, although I've used this in previous semesters with this 300 students and it's been fine. So it might be something on their end. Yeah. The Wi-Fi. Yeah, so as I said, I haven't been in this classroom specifically. I've been in other classrooms where it works fine. And so maybe like I said, maybe it's because we're like more internal into the building as opposed to some of the other classrooms. But like I said, getting logged on at the beginning of class, you can already see we're up to 250. I think that should help alleviate that issue. I'm not going to use them for points today because I realize that we are kind of having this until I get a better technical response from them and a way that we kind of approach this. I'm not going to kind of use today's for points. Okay. All right. And then I'll generally say, okay, time's up. I'm going to close this out. If you haven't gotten an answer in, make sure you get your best guess in there. And then I'm going to close it out. I'll then move the next one. Start the question. You have a similar one here. So this one, what's going to be the opportunity cost? So to the point earlier, I'm not going to give you any negative values trying to trick you, right? These are all positive. So if I'm thinking about what's the opportunity cost for one more unit of butter here, this is actually kind of an easy one because I asked you for the cost of the x-axis good. So what would you do? Rise over run, change in y over change in x. What is your change in y? 600 to 0. Change in x, 0 to 800. 600 over 800 would be 0.75 or 3/4. Where is that at? There we go. And it's always in terms of the other good. Okay. So generally, this is how these will look. I'll work through some stuff that's very similar. In fact, I worked through stuff that's a little more complicated than even this. And then I'll ask you some questions just to make sure you kind of, I can look at the responses and see how well people were kind of following along. Okay, how well people were kind of getting it. And also give you some nice, easy effort-based points. Okay. All right. Any questions on this one? Yeah. So actually, this is a good test. You haven't been able to select anything, right? Yeah. Yeah. So I think that, like I said, I think that their response to me is going to be either contact building services and get like a Wi-Fi amplifier, or probably tell you to log on at the beginning of class. That way people, it's going to take some time, but everyone will at the point I use it. Because I usually don't start the class off with them, I'll be completely honest. So, if you're running 5 minutes late, I should tell you this, but you probably won't miss the in-class question. But, if we all get on at the beginning, then by the time I use it, hopefully everyone will have kind of gotten on given the Wi-Fi. But I may have to, like I said, I may have to talk to building services or kind of help some other people with some ideas that they've used to kind of get around. But I'm waiting on a response. I already sent them an email. So hopefully by Thursday's class, I have a good answer to this or a good solution to this problem. Right? But we're getting close, right? It's at 90%, right? We got 300 people and we're just over 270. So hopefully, like I said, starting at the beginning of class, then by the time I get to them, we won't have to run this. Any other questions in this before we keep moving? Should be pretty basic, straightforward. Okay. So those of you who are logged on, or how many of you were able to kind of see the question? Just give me a show of hands. Okay, so it's a good amount, but yeah, it is kind of slow. Hopefully logging at the beginning, or like I said, I'll get a technical response from them about something we can do to alleviate this. But I just wanted to kind of show you like what the questions look like and kind of how I'll be using them in class. Right after we cover some material, I'll ask you very similar questions in the top half, okay? All right, so get out of that for now. And I just put them in the complete version of the slides as well. So sometimes if I have pictures or something, if it's easy for me to embed them, when I post the complete lecture slides at the end of the week, they might even have some of the top hat questions in there so you can kind of have it all in one place to review. Okay. All right. Oops, started there. Okay, we should be all right. So let's say I had the same setup, right? And I want to kind of go through why gains from trade can be better for both of these countries. Okay. So if you think about it, if we only rely on ourselves, we are going to have to trade off. We're going to have to give up the production of one good to get more of the other, right? But maybe someone else could do that at a lower cost. So it'd be great if I could rely on them to do it, and then I'll just produce what I have a lower cost in. And then we can kind of trade goods back and forth, both be better off. So numerically, how would this work and how is it going to make everyone better off? So if we think about India, from India's point of view, we said their cost to an aircraft part was they had to give up 5 iPhones. So if the US comes to them and says, hey, look, if you were to produce this yourself, you'd have to give up 5 iPhones to get one more aircraft part. We'll give you an aircraft part if you give us 4 iPhones, right? India would be like, okay, yeah, because I would have had to give up 5. Now I only have to give up 4. I'm okay with that terms of trade, sorry. And then the US says, okay, what was our cost of producing an aircraft part? Well, we were going to have to give up. Oh, now I forgot what their cost was. Was it one aircraft part was going to cost them 2 iPhones, right? So if I want an aircraft part from them, they're going to have to give up the production of 2 iPhones. Well, now, or sorry, if they give up producing an aircraft part, they're only going to get 2 iPhones in return, right? Well, now if I make that aircraft part and trade it, well, now we agreed that India would be willing to give it to me for 4 iPhones. So I'm now better off by relying on them to produce it instead of switching the production over myself. Okay? So they're okay with any terms of trade above 2, right? Because now they're getting back more iPhones than if they produce it themselves, right? So our kind of terms of trade will always be in between the 2 costs of the 2 different countries or 2 different individuals or companies, like depending on what we're kind of looking at, specific problem. But whatever the 2 individuals' costs are, the terms of trade, anything in that range, they're both going to be better off, right? Because now India is having to give up fewer iPhones, right? To get that one aircraft part, they can keep producing iPhones and then just give up 4 of them to the US and get an aircraft part. The US can keep on producing aircraft parts, and instead of stopping the production of 1 to just get 2 iPhones, they can keep producing that aircraft part, trade it away, and now get 4 iPhones. So that's going to be the kind of intuition behind why trade can be beneficial for both. We could do the exact same thing the other way, right? It's just the cost would change. And now our terms of trade for the other good, we had costs were 0.2 and 0.5 or 1/5 and 1/2. Anything in between those 2 values, both countries are going to be better off if we agree to some value in the middle of that range. Now, what we're going to do in this class is simply identify the range. Later on in the semester, we actually will talk about some issues as to if people have more bargaining power, right? There's a lot more issues come into play because ideally, like in this scenario, what was it? The US cost to an iPhone was half an aircraft part. So ideally, they would like this terms of trade to be as low as possible. They'd like to give up as low as possible, right? They'd like to be closer to that 0.2 value of this range. And India would like it to be closer to 0.5. So there is going to be this kind of back and forth in practice where we bargain over what this terms of trade is, but we know that we can come to agreement as long as that value is somewhere in the range of both of our costs. Okay, we can both be better off by trade if that value is somewhere in the range. Now, exactly where it is, issues for later on in the class, and also really issues that you'll probably talk about later on in some of the courses that you take in Keller. Okay. So, terms of trade for the opposing good, it's really just the cost of the other good, right? And you really could go back here. So we had 1/5, sorry, we have 2 and 5. If I take the inverse of both of those, so this was the terms of trade for the cost of an aircraft part, how many iPhones had to be given up? If I just take 1 over both of those, it's the same sort of thing that applied to when we have a comparative advantage. The terms of trade would just be 1 over both of these. So 1/2 and 1/5, right? But not kind of notice, we go back here, 1/5 now becomes the lower end of our range and 1/2 becomes the upper end, right? But we could find those costs of our y-axis goods, and then the terms of trade will just be in between those 2 costs as well. Let's give it just some numerical support for this. Let's say before trade, both of these countries were only relying on themselves. So I think maybe this will make a little more sense. So they're only relying on their own production to get both of these goods. So the US has got 15 iPhones, 22 and a half aircraft parts. That was one of the points that was on their production possibilities curve. And then India's got 25 iPhones, 5 aircraft. That was a point that was on their production possibilities curve. If we have both countries only produce what they're most efficient at producing, or they can produce at the lowest cost, we would have the US producing aircraft parts, producing 30, India producing only iPhones, producing a total of 50. Okay. So we said that, oops, there we go. Anything in between 2 and 5, the cost of an aircraft part, anything between 2 and 5 iPhones, both people would be okay with that and be better off if we had that as our terms of trade. So I can kind of show you, prove to you why, right? So let's say they agree to the cost of an aircraft part being 3 iPhones. The US kind of agrees to give 5 aircraft parts over to India. So at the cost of 3, that means that when they're giving up 5 aircraft parts, for each one, they're getting back 3 iPhones from India. So they're getting a total of 15 iPhones. Now, they were producing only aircraft parts, so they could produce 30. They had to give up 5, like they were trading 5 away. So they end up with 25 aircraft parts. But when they traded those 5 away, they got 15 iPhones, right? Same kind of thing. India was only producing iPhones, but when they traded away those 15 iPhones, they got back 5 aircraft parts, right? So they were producing all iPhones, they traded away 15, but got 5 aircraft parts back from the US. So if I just kind of compare those values now, right, you can see that the US is getting the same number of iPhones, but more aircraft parts, and India is getting more iPhones, but the same amount of aircraft parts. Both individuals or both countries in this example are better off after the trade. Yeah.
Actually, we got the 30 and 50.
Yep. So we have to go all the way back to this table, right? Because we said we're kind of coming to an agreement to trade. We're both only going to produce what we have the comparative advantage in. So the US only produced aircraft parts, 30. India was only producing iPhones. And then from those values, it was just, well, how many aircraft parts is the US trading away? 5. How many iPhones was India giving the US for those aircraft parts? 15. And then we could come up with these new values. Yep. Any other questions on this? And I chose these examples just to make it very obvious where you have the same of one good, but more of the other. You could actually work out, this where you actually end up with like a little bit more of both, right? And if you didn't just want to have more of one good, but I think this is like nice, easy, and clear to see. The other numbers would be like, there'd just be more decimals and things like that. I think it's really easy to see here. Oh yeah, we have the same amount of one good, but more of the other, we're both better off. Okay. So, and this is kind of all under the assumption that we've identified who has a comparative advantage, and they only produce what they have that comparative advantage in producing, and then we trade. Okay? In fact, we could get along more in this world. We wouldn't need two country models. Every country would just produce what they're good at, and we would all kind of trade back and forth. So, like free trade, these are some sweet Nikes you have on, right? Because everything, there's so many goods that, yes, we might have an absolute advantage in producing, but if we didn't rely on someone else and trade with them, we'd have to be producing those things at a higher cost to ourselves. In our economy, we wouldn't have as many things. So free trade increases the overall amount of these goods that the entire world can have, or that both individuals. Okay. All right. So I think I left another slide open. We've got a little bit of time, so let's go switch it up a little bit. So we've got that terms of trade. We're going to switch gears a little, but still thinking about like we had 2 countries. I'm going to now kind of switch it to not thinking about countries, but more of like individuals. So we're going to look at what we think about as the economy-wide production possibilities curve. So let's do agricultural goods and then tech goods. So we don't even have to put a specific name to these. We can kind of think about these as like I said earlier, sets of goods. Maybe we want to put our resources more towards growing food to feed our people, or technology to kind of, give people better lives, right? Come up with, new discoveries that make our lives easier and make our lives better. So you can think about every single individual has their own production possibilities curve, right? Just like every country has their own production possibilities curve. So initially, if we think about who are we going to want to rely on to first start producing agricultural products, whoever can do it at the, choosing everyone in my economy, whoever can do it at the lowest cost, right? Whoever is giving up the least to start producing that first unit of agriculture, wheat or whatever it is. Okay? This will make me sound like, whatever. So, so this is kind of country granola of me, but my wife and I go to the farmer's market a lot on Saturday mornings here. If you haven't, they have like a lot of really good stuff. Like, first of all, I'll brag. I don't know what the person's name is. I just know where their stand is located. They've had like the best peaches that I've like ever had this summer. And then there's a corn stand people wait for, but like it's not that great. So don't waste your time for that. You can get just as good at Kroger. But I bring this up because there's a lot of people who are there who are Mennonite. I don't think they're Amish because a lot of them drive there. So I think they're Mennonite, and they can produce a lot of these different crops at a pretty low cost. So we might want to start relying on them initially because their production possibilities curve to producing agricultural products, they're really good at it, right? They've like honed this craft, and they like are like, there's a pepper guy there that like, I don't know, he talks my ear off every time for like 10 minutes and I don't really listen, but they can produce at a very low cost. Well, now over time, who do I have to start relying on to produce more of these agricultural products? People like me who try to grow like tomatoes in their backyard and literally get like one bowl the entire summer full. So it's like, people who can do it at a much, much higher cost, right? I could have been doing a lot more valuable things with my time. So this kind of continues as I start relying on people who can produce this good at a higher and higher cost. What is the slope of this curve? That's the cost of the x-axis good. So as my slope is getting steeper, what that's representing is to get more of this good, I'm actually having to rely on higher and higher cost individuals. Okay. So our economy-wide, I kind of drew it in segments here representing peoples, but usually we just draw it as this kind of nice continuous kind of line, right? So our production possibility curve has this kind of downward sloping, but it's kind of bowed out as well, right? We're relying on people who can produce this good at a higher and higher cost, okay? So I can think about this as, here I've got my agricultural products and my tech products, right? So I can choose any point on this production possibilities curve. I can get any combination of these two goods. It's just that wherever I stop, there's going to be a certain cost to producing one more of that x-axis good. So we can take this economy-wide production possibilities curve. Any point along here, I'm using all of my resources to produce both of these goods. We would call any point on my production possibilities curve, maybe you remember this from the reading, but production efficient, right? So production efficiency is going to be when I'm producing using all of my resources, I'm somewhere on this production possibilities curve. Allocative efficiency is going to be this idea that, okay, look, if I'm just thinking about, and I could put like this in dollar amounts, right? The value of this, and I could put it in terms of the other good if I wanted to. But as I produce more and more agricultural products, we said, what's happening to the cost? It's getting larger, right? So this is going to be we end up calling this, and we use it a lot this semester, the law of increasing marginal costs, right? As I want to produce more of something, I first use my most efficient resources on it, right? Or I'm producing at the lowest cost. Well, over time, I have to start using less and less efficient resources, less and less efficient people at growing these agricultural products. So I have this increasing marginal cost. Okay. I also can think about if I start from a point where I only had technology goods, I was only investing in those, and I'm not putting any money into agriculture. Nobody is growing any food. You think that's the best for society? Well, no, my people die. It doesn't matter if I've got computers, right? So we can think about initially the additional benefit to growing like that very first crop. It's huge. I'm starting to feed my people, right? Now, as we start to produce more and more food, well, you can only eat so much. I want to make sure I'm full, but if I only have 2 versus 3 meals, it's not the end of the world. As we start to produce more and more of a good, its additional benefit or the marginal benefit to society is declining. right? The very first few units I have of something that's kind of, I think I talked about this like last week. You as an individual, when you go from 0 to 1 car, huge marginal benefit. Going from 1 to 2, not near as large. It's the same idea here. As you have more of something, that marginal benefit is declining. So we said last week, when do we choose to do something? As long as the marginal benefit is greater than what? Marginal cost. We have a nice visual of this. The marginal benefit is greater than the marginal cost all the way up to this unit. Now, we won't use this terminology quite yet. I'm just going to introduce it because we will throughout the semester. But we can kind of think about this point is like what you might have heard, and if you took like an econ course in high school, equilibrium, right? Or this is the point that we say is allocatively efficient for society. So notice you could map that up to exactly what combination of these two goods is going to be what we call allocatively efficient. Right? These points are productively efficient, but notice we're still leaving like net benefits on the table. If we stop here, yeah, the marginal benefit's greater than the marginal cost at that quantity of agricultural products, but we could have had more positive net benefits if we would have produced a little bit more. Right? So this idea of allocated efficiency, there's only going to be one allocated efficient point. There are several productively efficient points or productive efficient points. Okay. Now, can you actually put a number to this? I'm not going to like give you one like that yet because it's really hard to evaluate these marginal benefits. But we know that this is the theory, like that we would have these declining marginal benefits, and there does exist some point that we should stop at that would be allocatively efficient for society, right? And if we continue to go past that point, well, now we've got like negative net benefits, right? The marginal costs are greater than the marginal benefits. Okay. Any questions on this before I keep moving here? Yeah.
Does that say on the top left of the bottom page? Next to the graph.
This?
No, bottom page. Next to the dot.
Here?
The top left.
Top left.
Yeah, that.
Oh, this thing? It's like the dollar value amount. Yeah, sorry. It doesn't have to be dollar amount. You could put it in terms of the other good. But once we get later on the semester, we're talking about these marginal benefits, marginal cost. Typically, we always kind of think about that y-axis representing some type of dollar value that we can put to it. Yep. Any other questions on this? Yeah. Yep. So all of these we're representing. Here was the marginal cost at this productive efficient point. It's just that it wasn't allocated efficient because the marginal benefit was still greater than the marginal cost. This is going to represent, here was the marginal cost to this productively efficient point, but we're still, like I said, leaving net positive benefits on the table. So every point here, if I'm thinking about really what I'm doing, use my red one here. So like this point, I could produce at this point, and my slope, I try to draw kind of a line that can hit that slope. That would tell me what my marginal cost is at that quantity. And then, but this point is productively efficient. I'm using all of my resources to produce both goods. If I move down here, well, this point is productively efficient too. The slope is much steeper, which represents that at this quantity, my marginal costs are much higher. Does that help? Correct. You could, I mean, in all actuality, you could be producing at this point. That was my initial like example, only producing technology goods, no agricultural products. We know, I mean, just intuitively, that's not the allocative efficient point for society. That's not going to be where society is the best off. So we have all these different points that we could produce at, but only one of them is going to be what's best for society. Now, how do we determine that? Gets a little tricky because it's really hard to evaluate what the marginal benefits to an entire society is. But this is the general idea that we're going to kind of start out with. Okay? We'll talk more about indifference curves and things like that later on in the semester and be able to kind of identify these allocated efficient points a little bit easier. But I'm just kind of introducing the idea now. Okay. See another hand. Any other questions? Oh, I saw something. Okay. Let me see. I might stay here. Where we at in time? Yeah. I'll go back to the slides, but I want to do one more thing here. So we have this kind of difference between production and allocated efficiency. There's also going to be three different types of zones, I guess we talk about. So anytime I have, and it doesn't matter here, we could have any two goods. So quantity of X, our X good, the quantity of Y being our Y good. Here's our production possibilities curve. Okay. I said any point on our production possibilities curve, we can kind of think of as production efficient, or I'll use this word of it's attainable, right? It's not only is it attainable, but we're using all of our resources, right? We can't get any more. We've used all of our resources at every point along that production possibilities. Any point past this, if I wanted to produce this combination of X and Y, well, why can't I? I don't have any more resources, right? I can't get past my production possibilities curve. Any point outside of, or kind of up and to the right of my production possibilities curve, we would say is unattainable, right? We don't have enough resources to get out to that point. Now we'll talk about things Thursday, which you might have seen in the module reading. How can I maybe get my production possibilities curve to shift out so that it does become attainable? Technology advances, increasing my population. We'll talk about a bunch of those factors on Thursday. But purely the zones, if this is my current production possibilities curve, without changing it, all these points out here are unattainable. Okay. You know, you can think about the most extreme. If I was here, I can't get more of this x-axis good because I've already used all my resources. Okay. Every point underneath my production possibilities curve, well, here it represents that, well, if I could have the same amount of X and my production possibilities curve is telling me I could be producing this much of Y, what am I doing here? I'm being inefficient, or I'm not using all of my resources, right? So we've got these kind of inefficient points that are underneath our production possibilities curve, unattainable points, points that are past it, and then any point on the curve is what we call we're being productively efficient, or production efficiency, or another word I might use. All right, those are attainable points using all of our resources. Mm-hmm. Oh, out here? Anything to the left of this?
That's on the ground.
This?
Yes. Yeah, that's fine.
So if I were to move here, that point would not be, right? It's underneath my production possibilities curve. If I were to move to this point, I am still at a production efficiency point, or a production efficient point. It's just a different point, right? I have more of one good and less of the other. So I have to be on this curve to be considered production efficient. Any point underneath the curve, so all these points are inefficient. All these points are unattainable. They're outside of our curve. Is that what you're getting at? Yeah.
Figure out that line. You can give us that.
Yeah, I would have to I'd give you a visual representation. So in practice, you could go through every single person in your economy, right? Figure out their costs, and then you're just graphing those out. I would, if I'm asking you a question, hold on. Skip ahead here. So this would have been the third question we used if Top Hat was kind of up and running today. So actually, I might go back and see how many people actually got on. But I would give you something like this. Which of these points is inefficient? D, right? Like I said, I'll work through something. These should be pretty easy questions as long as you're paying an ounce of attention to what I'm doing up here. Okay. Yeah, let's check and see. And so, unless some of you might have closed it, but I'm not even going to use it for points, so I just want to see. Okay, a lot of you got out of it. No problem. That's all right. We'll try it next class. So here was kind of what we're looking at, kind of thinking about allocated efficiency versus production efficiency. I already drew all this out for you, but this is kind of a summary of everything we just talked about. right? Any point below our production possibilities curve is inefficient. Any point past it is unattainable. Our marginal cost, the reason why our production possibilities curve is bowed out is because we have to start relying on people who can produce that x-axis good at a higher and higher cost, right? Or we have these increasing marginal costs or increasing opportunity costs, the more and more we produce of something, okay? And then I already drew these in there for you. We can kind of think about here. I inherently kind of drew this out for you and talked through it, but we also not only have the law of like increasing costs, we're also going to have the law of diminishing marginal benefits. So the more that I have of something, the less and less I'm going to get additional benefit as I'm buying or consuming or producing more and more of it. So that was how we kind of came up with that increasing marginal cost, decreasing marginal benefit, and identified that point where it was allocated efficient for society. We continue to produce or change our resources over to producing that x-axis good, all the way to the point where that marginal cost is the marginal benefit of that very last x-axis good that we produce, right? And that's kind of the visual that I gave. So this becomes kind of difficult. Like I said, it's hard to kind of get an idea about exactly what those marginal benefits are. Once we get some later modules, we'll start to actually think about this on like an individual level, and then to do it on a country level, we would just have to scale it up, right? But for now, increasing marginal cost, diminishing or decreasing marginal benefits. We already looked at allocated efficiency. We will kind of start off next class thinking about things that will shift our production possibilities curve, okay? So at the start of next class, make sure you're getting logged into Top Hat. I think that should help resolve the issues until I get some further information. Also, after class on Thursday, I will make available the next quiz. I'll also put up the next module reading tomorrow when I'm in my office in the morning. So you kind of want to start in that early. That'll be due. Both of those due when? End of the day on Monday. All right. All right. We'll see you guys on Thursday.
Thank you.
Yeah.